Hello everyone and welcome to this video on Unit 8 of AP, Area Between Curves. Okay. And to understand how to find the area between two curves, as long as we have a pretty good understanding of what the integral actually is, then this is no big deal. Let me put a couple new layers here. There we go. So let's say we have a curve, I don't know, like this. Okay. This is going to be curve 1. Let's call this y1, which is just f1. Okay. And let's have a second one here. And what we'll do, we'll start this one off here. And so we have something like this. Okay. And the thing that we want to do is we want, well, oops. Let me put that on a different layer. Okay. Sorry about that. Anyway, so the area that we are interested in, okay, is going to be here in purple. We're interested in literally the area between these two, okay? And if we remember that integration of a curve gives us the area between that curve and the x-axis, then doing this isn't so bad. All we really got to do is subtract the two, okay? So this is the area we're interested in, and how are we going to get it? That's what we're talking about. Okay, so very nice. So let me see if we can toggle that. Yeah, so that's the area that we care about. Now let's talk about the areas that compose the area that we're interested in. Okay, so let me do blue for blue. All right, so if I do, let's call this x equal, I don't know, let's do x equal 4, okay? So if I integrate from 0 to 4, f1, then that's literally going to give me the area, or the accumulation from 0 to 4 of the blue curve. In other words, it's going to give me this area right here. So first it's going to be negative, okay? First the accumulation will be negative. Then this accumulation will be positive. So just the blue curve. Remember, the red one, the red one and the blue one are two different things. If I integrate just the blue one, and that's going to give me a hard stop there, just like that. Okay. Now, here's one of the things that we have to worry about. Okay. One of the things we have to worry about is the fact that we have a negative accumulation here and a positive accumulation here. So, in other words, if I just do the integral from 0 to 4, it's not going to give me the area, okay? It's going to give me something smaller than the area because this thing's negative. In order to find the total area, we need to make this positive and then add to this one, okay? So, in other words, area must be positive, okay? Area must be positive. Okay? And so what we really have to do, and let's just say, I don't know, let's say just for simplicity's sake, let's say this is x equal 1.5. Okay, so what we really need to do to find the area of just the blue curve is we need to integrate from 0 to 4, but we need to do the absolute value of f1. Okay, so this is how we find the area. This is exactly how we find the area between any curve in the x-axis. Okay, the total area. Now, how to do this in practice, right? Notice f1 changes sign at 1.5. In other words, from 0 to 1.5, curve 1 is negative. Okay? So what I actually have to do is this. I need to do the integral from 0 to 4. I'm gonna kind of abbreviate here. The integral from 0 to 4 is going to be the integral from 0 to 1.5. Okay? Now again, the curve is negative. So how do we, what do we do to make this thing positive? We just multiply it by -1. So 0 to 1.5 of the negative of f1. That'll make this positive, okay? And then plus the integral from 1.5 to 4. And that gives us this bit right here, okay? And it's still the same function f1. We don't have to do the negative again because it's already positive, right? So just keep it. There we go. Okay, so that is how we would split that up just for f1. Okay, now let's turn our attention to f2. Oh, very nice. Okay, cool. Yeah, very nice. So I can just toggle that whenever I want. Very cool. Now for the second curve. Okay, the second curve is positive only, right? It never goes below the x-axis. So if we, do this integral here, the area it's going to give us is the one that I am highlighting right now. Just the red, okay? Just the red. And notice that, this thing never goes negative. So we don't have to split it up like we did the blue one, okay? So in other words, the area of the red one, let's call it A with an R there, area of the red, is just going to be integral from 0 to 4, and I haven't given this one a name. Let's call it F2, right? Whatever this thing is, the red curve is F2. Okay, all right. So anyway, so that is how we would find the area of the red one. Again, technically it is absolute value, but because it's positive everywhere, the absolute value of a positive number is just that number itself, okay? So we don't actually have to worry about the whole split thing, like I was saying before. Okay, good. Now, okay, let's look at these areas. There's this one, and then there is this one, right? Now, how can we use these to get that? Well, look at that, right? So as we can see, there's some overlap here between these two. So if I, for example, if I do the area of the blue one and then the area of the red one here, if I add those together, then I'm going to be, so, I'm sorry, I can't speak. This region will be counted for twice, and we don't want that. Okay, so so again, right? How can we just get the purple? Oops. How can we just get this right here? Well, what if we subtract, right? What if we find, for example, if I look just from here to here, If I find the blue area, which is that one, and then subtract the red from it, right? So boom. So imagine we subtract that red out. If we subtract that red out, then all we're going to have left is the purple. Okay? So finally, everybody, we arrive, finally we arrive at our conclusion for area between two curves. So what we're going to do is we are going to integrate, and again, it's going to be basically top minus bottom. Okay, top minus bottom if it's an x thing, and it's also possible to integrate with respect to y. And if that's the case, if you're doing a y situation, instead of top minus bottom, think about what makes, think about what's more positive, right? It's going to be right minus left if we're doing a dy integral. Okay. All right, very cool. Okay, so so now we have the theory for how to find these areas. And before we jump into an example, notice right here, the top and the bottom change. Okay, so you need to be looking at this all the time. Here the top one is F2. Here the bottom one is F1. Here the top is F1 and the bottom is F2. So we would have to split this, right? Let's say that was 1. We said that was like 1.5. I think we said that was 1.5. That was 1.5. X equal 1.5. Okay. So we would have to do the integral from 0 to 1.5 of the red minus blue, and then plus the integral from 1.5 to 4, and this time we would do blue minus red, okay? So that's how we'd find the area between those two curves. All right, okay, so now let's actually do an example. Okay, so here we go. Let's do F1 is e to the x, F2, let's make that the square root of x. Okay. And then this problem actually gives us bounds as well. X equals 0, x equals 1. Okay. So, let me get this up here. Yeah. So if we graph this thing, we'll get a pretty good idea what's going on. E to the x, good old exponential function there. Okay. The square root of x, you know. All right, yeah. Good. There's those, and then we have x equal 1 is a bound as well. Okay, so we're talking about like something here. Okay, and we want the region bounded by the curves, the area between the two curves. Okay. So that's kind of the first thing that you want to think about is, what's my region? What's my region? What's my region? Okay, please think about the region. This is the region. Okay, so this region, once again, starts at x equals 0, stops at x equals 1. The top function, that's our exponential. And the bottom function is our square root of x. Okay, So to find the area, we're just going to do the integral from 0 to 1. And then it's top minus bottom. So e to the x minus the square root of x and dx there. Okay. And now if we integrate this, we're just going to get e to the x, and this is x to the 1/2, right? So we're gonna add 1. So 1/2 plus 1 is 3/2. Divide by 3/2 is the same thing as multiplying by 2/3. Very good. So there's the antiderivative, and then we're going to evaluate from 0 to 1. Okay, so we get e minus 2/3, and then minus 1, right? Put in that, minus 1. And then minus and minus is a plus. And then 0 to the 3/2 is just going to be 0. All right, so now we just get e minus 2/3 minus 3/3, which is going to be e minus 5/3. There we go, and I happen to pull this one out of the book, and it's correct. There we go. It didn't give us units, so we can be safe, and we can just say whatever the units are, they're units squared, because we're talking about area. Okay, all right. So there's that. We got the theory down. We have a simple example. There we go. Area between two curves.